Hi, a friend of mine asked me to look at this because I've done a lot on the basics of supercapacitors, quite a lot actually, and not built that many of them. But he was looking for a solution, and he wanted something that would have pretty good power density, be relatively simple in its structure and relatively safe in its structure. So I had to cast around the lab to see what kind of things I could build a supercapacitor from. And the first thing I came across really was this. It's just a laminating sheet. Now, it's pretty heavy. That actually weighs about 12 grams. It's a 50 micron sheet, and the weight becomes important later on because I'm just using materials that you can get your hands on easily and I have lying around. So the main encapsulation and the support is going to be this laminating sheet. So I put everything on that laminating sheet. Now for the collector plates, I use this stuff. This is the kind of aluminium that you can buy at the builder's store. And the amount of aluminium I used on this was about 6 grams to make a couple of plates on there. And I basically stuck them on the inside of the laminating sheet and gave them a rough going over with a bit of wire wool, just to give it a bit of surface really, nothing challenging. So I stuck that down, give it a going over with the wire wool. And then I painted it with this stuff. Now this is the graphene powder I make. And I mixed that up with some polyvinyl alcohol, 10% solution actually. So there's 10 grams of PVA, 90 grams of this, and 100 millilitres of water made me my supercapacitor paint. And all I did with that was paint it onto the aluminium that I'd just gone over with some wire wool with a brush and left it overnight to dry. Then as a separator I used this stuff. This is glass fibre matte. It's about 2 grams in weight or so, and I've stuck the plates down, painted them, popped the separator in between, and then passed them through a laminator to make what you can see here, which is the final laminated supercapacitor. So really easy to make. Now, for a electrolyte, what I decided to use was good old sodium chloride. So I dissolved 25 grams in 100 millilitres of water and took 8 millilitres of that and squeezed it into the centre to form my electrolyte. And that's my basic supercapacitor all done. Now, I've got it wired up to my voltmeter here. So 2 of the leads clip on to either side of the capacitor. Then they clip onto this resistor, which is 270 ohms, and then I've got them attached also to this battery. So all I have to do is touch the end of the battery and it will charge the supercapacitor. Now I don't want to touch it on completely because that's a 1.5 volt cell. And these things are susceptible to Faraday reactions. So if you put a bit too much charge in there, you can actually hear it crackling. So what I've done is I've got a wire bound resistor here and I'm going to charge it up through the resistor so that it slows it all down a bit and I can get a bit more control. So I'm going to charge it up to 0.575 volts. What that means is that it's going to have to discharge to 0.211 volts. Now, what I'm looking at is calculating the capacitance here, and for that I need the time constant, the tau. And the tau, when it's discharged at 36.8% of its original volt charging, so I'm going to charge it at 575, discharge 0.211, which is at 36.8% of 0.575. I'll time that, and that will give me a figure that I can plug into an RC time constant to work out what the capacitance is. So the tau is equal to RC. Given I've a known resistor there, 270 ohms, given I'm going to discharge it to 36.8 of its original charge, then I'll be able to multiply that through and work out what the capacitance is. Now, I've done this about 10 times already, and it takes about 16 minutes to discharge from 0.575 to 0.211. So I've been at this a couple of hours, and to be honest, I'm a bit bored. I've only got another 9,990 to go, and I'll be able to say that the cycle time is brilliant. So all I'm going to do is charge that through that, and then discharge it by taking that off, leaving it alone, and timing how long it takes to discharge. So once you've discharged that, then you can say with reasonable confidence that you have a figure you can plug into calculation. Tau equals RC, and in this case 16 minutes and 6 seconds, which is 966 seconds through a 270 ohm resistor, gives me a capacitance for this stupid little thing of about 3.6 farads. So that didn't take me very long to make, and I got 3.6 farads out of it. Now, this whole thing weighs 32 grams, but of that, 12 grams is plastic. If we take the whole thing as one piece and weigh it and look at that 3.6 farads, then the energy density here, if you like, is 112.5 farads per kilogram. I figured that that wasn't particularly fair, so if we take away the plastic and we just look at the structure on there of the aluminium, the separator, the fluid and the capacitive paint, then we get 180 farads per kilogram. Now if we take away the aluminium from that and just leave the fluid and the paint, then we get something around about 300 farads per kilogram, and the material itself is about 900 farads per kilogram. So we're looking at a basic structure here that really has had nothing in the way of work done on it. I haven't tried to etch the aluminium properly. I haven't really done that much in controlling the thickness of the material that I've put on. I've whacked a piece of separator in there that I just happened to find around in the car shop. So I haven't done much out of this, and we're getting 3.6 farads out of that, and an energy density in the region of 900 farads per kilogram. Pretty cool, I thought. Anyway, I hope that was of interest to you, and thank you very much for watching.